21. Virus can cause cancer by all of the following, except virus causing cancer. So far, we have those hypotheses. When it's inserted into the genome, it can mutate the gene. It can specifically mutate the tumor reproduction gene. And activate the bad genes like oncogenes, proto-oncogene. And the virus itself may carry oncogene into the cell. Okay, that's how they induce the cancer. 22. Plaque assay are used for. What was the plaque here is you use the bacteriophage, okay, to duplicate inside of bacterial cells. When those cells are lysed, you see clear zone on the bacterial lawn. We call those as plaque. Remember, this is the petri dish. So, the lawn of bacteria. Okay, before you culture bacteria, you infect the bacteria with the phages. Then you spread bacteria on the surface of the agar, let bacteria growing. 2 days later, you see a lot of clear zone. Clear zone actually, the virus, those bacteriophages, okay, lyses the bacteria. So in these areas, you get clear zone. We call this as the plaque. Okay. Plaque assay are used for estimate the number of phages in a culture. Okay, in a bacterial culture.
Yeah, exactly. Yeah.
23. Diploid cell culture and a continuous cell culture differ in which of the following way? Diploid cell cultures and continuous cell cultures differ in which of the following way?
Yeah, I did it earlier.
They differ in longevity and also source of the cells. For example, many of the diploid cells, their generation, when you culture it, is limited. Most of the water cells is only divided for several times, then they no longer divide anymore. They're dying. But for the tumor cells, when you're growing, the generation is unlimited. Keep growing, keep growing. Okay. Unless you don't feed them with nutrition. 24. How are prions differ from all other non-infectious agents? This one's simple. You just know prion or protein, no nuclear. Yeah, no nuclear. No nucleic acids, sorry, no nucleic acids. All of the following are diseases known to be caused by prions. So far we know those diseases: Kuru, scurvy, bovine spongiform encephalitis. Okay, and Creutzfeldt Jacob's disease. So a lot of different names. Okay. DNA virus. And for this chapter, we may have a few questions overlap with chapter 13. 1. What is unique about the HEPA DNA viridine family of virus? This is the only one that contains both single-strand and double-strand DNA. DNA virus do not include which of the following family of virus? So this you need to remember. We have those adenoviridine, herpes viridine, pox viridine, papilloma viridine, the DNA virus. Okay. 3, all of the following are true of pox virus. Okay, pox virus except. Firstly, they are spread by close contact. That's why the kids mostly are easily to get this. The genome is double-strand DNA, and they are enveloped. And the symptom including skin lesion, most common symptom. Four, which of the following statements is true of both molluscan contagion and smallpox? The virus come from the same family, pox viridine. 5, all of the following factors made it possible to eradicate smallpox except. Has the ability to grow the virus in laboratory animal. It's difficult.
What was that?
Can you repeat that?
So to eradicate smallpox, because number one, there's no asymptomatic cases, right? And the symptom is very clear. Any people have it, you can see the lesion on skin, so you can isolate. Okay. And it's only in fact in human, no animal reservoir. And a cheap vaccine is developed. So a lot of government can afford to provide to its population free. Okay. Because of that, so eradication smallpox is possible. Okay, and indeed, because of this. 6, all of the following statements concerning molluscan contagion are correct. Number 1, those virus is very common in certain islands. Okay, certain islands in the Pacific Ocean. Producing very smooth, waxy tumor-like nodules on skin. Can be transmitted sexually. It causes neighboring infected cells to divide rapidly. So a new tumor-like nodules will be grown just next to it. 7, all of the following are true of the latency of herpes virus, except. So herpes virus, as you remember, they can living in those ganglion, right? In the ganglion of spinal nerve ganglion, so they can be reactivated. Okay, so shingle is one of the example. Okay, showing you the reactivation. Okay, and herpes virus can be a trigger for cancer. Okay, and its genome can also incorporate it into the host cell chromosome. The factor for reactivation could be a chemical